Hello dear students, welcome to Byju's Exam Prep. So in our today Ground Zero series, we will discuss one of the most important topic from the RCC subject, that is basically the analysis of stress block parameter. So you know that guys, whether it is a singly reinforced beam or doubly reinforced beam, you need to understand how to analyze the stress block parameter, because after analyzing this particular thing, you are able to understand what should be the force like C force, what should be the T force that you have to apply or that should be developed in the beam to resist any kind of bending moment, right? As well as there is one more important thing, that is basically our lever arm, right? So how to calculate the lever arm? That means the distance between these two forces, how much it is. So all these things we will discuss in this particular session. Now guys, you may find the further lecture also in which we will discuss like about the actual depth of neutral axis, critical depth of neutral axis or limiting depth of neutral axis. Then in the next session, I will tell you about the how to calculate the moment of resistance. And in the practice session, we'll discuss the problem related to this particular complete analysis part. Okay, so let's start this particular session and let's discuss how to analyze the stress block parameter. Okay, so guys, let us consider we have a cross section of a beam which is a singly reinforced beam and whose width is equal to how much? It is equal to B, right? And let us consider the depth of the beam is, overall depth of the beam is capital D. Now, if we have the value of effective cover, then we are able to calculate the value of effective depth, which is our small d. How we can calculate? Let me explain it. So you know that guys, if the dia of reinforcement is known to us, let us consider this is basically phi t value. Phi t is our dia of reinforcement, tension reinforcement, and let us consider this is our clear cover, right? So how we can calculate this small d? It is very simple. We can write here small d is equal to capital D minus this clear cover minus dia of tension reinforcement divided by 2, right? So this will become our effective cover. If you minus effective cover from the overall depth, you are able to get the value of effective depth, right? The next one is basically our strain diagram. In the strain diagram, you know that guys, the maximum permissible strain in case of bending compression, it is 0.035. This value is 0.02 as per the IS code. And the permissible strain in case of steel reinforcement which is present at the tension level is Fy divided by 1.15 ES plus 0.002. What is Fy? That is basically our grade of steel. What is ES? That is the Young's modulus of elasticity of the steel. If the value is not given, you need to consider it as 2 into 10 raised to power 5 Newton per mm square. So let me write it down. ES is equal to how much? It should be 2 into 10 raised to power 5 Newton per mm square. Okay. Now guys, another diagram which we have, that is basically our stress diagram. So in stress diagram, the stress at the level of tension steel is 0.87 Fy. How it is 0.87 Fy? Because we know that the permissible value of stress at the level of tension steel is given as 0.87 Fy, but the value of partial factor of safety in case of steel, how much it is? It is equal to 1.15. So you are able to calculate this very easily. Let me show you that guys. So permissible stress at the level of steel is equal to 0.87 Fy. How we can write it down? Fy divided by 1.15. So this is nothing as this is the partial factor of safety for the steel. If you calculate this, you are able to get the same value, which is 0.87 Fy, right? The next stress which is available at the top fiber of the concrete, which is in bending compression, it is equal to 0.45 FCK. Again, this is a permissible stress according to the LSM method. Now guys, how we can calculate this? Again, it is very simple. So you can write it down. The grade of steel is FCK, or you can say that, but not grade of steel, it is basically the characteristic strength of the steel is FCK. Now you need to divide this particular value with the partial factor of safety, which is basically 1.5, right? But there is one uncertainty factor which is recommended by IS code. You need to multiply that particular value, which is basically 0.67, right? If you calculate this particular ratio, you are able to get the value of 0.45 easily. Kindly do it guys, you are able to get the same answer like 0.45 FCK. Now you are able to understand how this particular stress is written on this particular stress diagram. Okay. Now guys, you can see here there is a distance between these two values, which is, let us consider x1, and the distance between these two value, which is strain, is 0 at this particular point, and the strain at this level is 0.002, which is basically x2. And let us consider the actual depth of neutral axis is xu, right? Now guys, you know that this is basically our AST value, which is nothing as total area of steel which is present at the tension level. Now what we need to do first, we need to analyze the strain diagram so that we can find out the value of x1 and x2 easily. Okay, so let's do the analysis on the strain diagram first. So guys, this is our strain diagram. Let's calculate the value of x1 and x2. We know the value of strain at the top, it is 0.0035, at this level 0.002, and at the level of tension steel, it is equal to Fy divided by 1.15 ES plus 0.002. Now guys, let us consider this is x1 and this is x2. And what is the value of x2, how we can calculate? By using similar triangle concept. Right now you are able to see here guys, at the level of xu from this location, the value of strain is how much? 0.0035. And at the level of x2 distance from this particular point, it is 0.002. If you take a similar triangle concept, you are able to get the value of x2 easily. And how much it will become? 4 by 7 times of xu. Clear? Now guys, you can see here the relation between x1 and x2 is equal to how much? x1 plus x2 is equal to how much? It is equal to xu, right? So if you put the value of x2, we'll get the value of x1 easily, correct? So kindly see this, x1 is equal to how much? Just a second, x1 is equal to how much? It is equal to 3 by 7 xu. Now you are able to get the value of x1 and x2. Done. Now guys, after this, we need to analyze the stress diagram. But to analyze the stress diagram, we should know how to calculate the forces in case of stress diagram. And there is one more point we need to understand. If it is a simple geometry, then we are able to calculate the centroid and the area of that particular shape easily. But guys, if you have a parabolic condition, then what should be the area, what should be the centroid location, that we need to understand. So that's why we need to discuss one simple funda for this particular analysis also. Like we will take one rectangular area and we will divide it in two portions. One is 2/3 of that area and second one is our 1/3 of that area. And we will discuss what should be the area exactly and what should be the centroid location. Okay. So this is nothing as our parabolic, this is our rectangular shape in which I have drawn one parabolic curve, right, which is trying to divide the area in two parts. One is basically 2/3 area and second one is 1/3 area. So let's understand what are the centroids we have. Okay, let us consider this is the length L, right, and this is our width B in this direction. Okay, now these are the two area which we have, 1/3 of B into L and 2/3 B into L, because the total area of rectangular is equal to how much? It is equal to L cross B, correct? Now guys, what is the centroid for this particular portion, right? What is the centroid of this particular portion? Let's understand. So this height is basically B. So the centroid of this particular area will be 3/4 times of B from this particular point to this point, and from this point to this point it is 1/4 of B. In the same way, we can write it down in the direction of length also, like it is 1/4 times of L in this direction and 3/4 times of L in this particular direction. Now what is the centroid of this particular area? It is 3/8 of L in this direction and it is 5/8 of L in this particular direction. Similarly guys, in this direction it is 3/8 of B and 5/8 of B. Now which area is major for us? We know that guys, in our stress block parameter and in our stress diagram, this is the area which is available in the compression zone, and this area we need to analyze, right? Let me show you that particular area in our figure. So you can see here guys, this is the area which is our 2/3 of B into L, and that we have to calculate it also, right? So guys, in the stress block parameter analysis, we need to find out what should be the total compression force and what should be the total tension force we have and what is the value of lever arm. So let us calculate the C1 force first, right? And then we will calculate the C2 force also. And then we will discuss what is the value of T force and what is the value of Y2 distance. What is Y2 distance? It is nothing as, it is the location of this particular C2 force from the top fiber. In the same way, what is the location of C1 force from the top fiber? That is basically Y1 distance. So let's find it out what it is exactly, and it is very simple. Okay, so guys, you already know that what is the value of x1 and what is the value of x2. Okay, now let us calculate the C1 force. So how much it is? C1 force is equal to how much? You need to calculate the area of stress diagram multiply by width of cross section at that particular level. So first of all guys, what we will do, we'll try to find out the area of this particular rectangular part. Clear? Then we will calculate what should be the width at that particular level in the beam. Very simple. So first just try to calculate the area of stress diagram, then width of the cross section at that level. If you multiply it, you will get the force. What is the force? Which is basically C1 and C2, right? Let's do it. So C1 force is nothing as, area is nothing as basically 0.45 FCK multiplied by this distance, which is basically x1. This distance is what? X1. So you will get the area of rectangle. So how much it is? It is 3 by 7 times of XU, 0.45 FCK, and what is the width at that level? It is B, right? So this is our area, and the value which we are getting is 0.19285 FCK into XU into B. In the same way, we'll calculate the value of C2 also. So what is the value of C2? Right now you are able to see it is a parabolic part. So the area of this particular parabola will be two-third of this distance and this distance. What is this distance? This is basically 0.45 FCK, and this one is 4 by 7 times of XU, right? So let's see the area of parabolic shape first, and then we will multiply it with our width. So 2 by 3 multiply by 0.45 FCK multiply by 4 by 7 XU and multiply by width at that level. If you take the product of it, you will get 0.1714 FCK into XU into B. And this is nothing as our C2 force, and this one is our C1 force. Are you getting my point? Very simple. Now the question is, what is the distance of this particular force, which is basically C1? This is a C1 force from the top. You know that this depth is how much? This depth is 3 by 7 times of XU. So exactly C1 force is applied half of this distance, which will be half of 3 by 7 XU. So guys, if you calculate this, you will get 0.2142 XU. Very easy. In the same way, we need to calculate the value of Y2 distance. Now Y2 distance will be how much? So kindly see this. This is our parabolic part, right? And let us consider C2 is applied over here. Correct? This distance is 3 by 7 XU. Kindly consider 3 by 7 XU. And then we have to calculate this distance, so that if we add both the distance, we are able to get the value of Y2 easily. So what is this distance? This distance is equal to how much? It is basically 4 by 7 XU. And if you take the 3 by 8 times of 4 by 7 XU, you will get this particular distance, right? And if you add it in this particular value, you will get the value of Y2 easily. And how much we are getting? 0.64285 XU. Now guys, I think all of you are able to understand how to calculate C1 force, how to calculate C2 force, how to calculate Y1 and Y2 value. Now after calculating this, what is our task? Our task is to find out total force in the compression side and total force on the tension side. Then we will find out the value of lever arm, and which is very simple. So guys, if you add C1 and C2 value, you will get 0.36425 FCK into B into XU, and usually you have written 0.36 FCK B into XU. That is our total C force, right? In the same way, what is the value of T force? Let us write it. T force is equal to how much? 0.87 Fy multiplied by how much? AST. So this is nothing as our T force value. Now after calculating T force and C force, we are able to calculate the Y bar distance. Y bar distance is nothing as, it is the location of the total C force from the top fiber, right? And I will show you that also, okay, in the figure. So how we can calculate it is very simple. Just you need to find out the centroid of the total force. How you can calculate C1 into Y1 plus C2 into Y2 divided by total C force. So C1 into Y1, C2 into Y2 upon total force, C1 plus C2. So this value which is coming around 0.42 XU, you can calculate it also, right? So guys, in final, we can say that this is our final stress block parameter which we are getting after the analysis. right? So which is nothing as our C force, and C force is equal to how much? 0.36 FCK B into XU. In the same way, what is the value of T force? It is 0.87 Fy into AST. And what is the distance of the C force from the top fiber? It is 0.42 XU value. So we know that this total depth is how much? It is D, right? So D minus 0.42 XU is how much? It will be our lever arm, right? So that's why, guys, we need to calculate it. Now you are able to understand why we are calculating, because after getting this result, you need to use it to find out the moment of resistance, to find out the actual depth of neutral axis, to find out critical depth of neutral axis. Now I hope all of you are able to understand this. Yes or no? Please comment in the chat box, guys, or in the after the video, so that I can understand. Also in other lecture, or in the further lecture, we'll discuss about the limiting neutral depth of axis as well as the our actual depth of neutral axis. And after that, in the third session, we will discuss the moment of resistance, also how you can calculate it, right? And in our practice session, we'll discuss all the problems which is related to this particular theory part. So I hope you have understood all the things which we have discussed today. Let's close the session, guys, and let's meet in the next one, in which we will discuss the limiting depth of neutral axis and actual depth of neutral axis. Bye bye, take care, and thank you so much for joining the session.